I adjusted the calendar for win days and stuff now. So now that we've had a couple of them, we kind of know how they're going to work out for timing. It kind of delays things a little bit, or pushes stuff back a little bit. We are going to be finishing the last section next Monday, so a week from today. Or the last section of this test. It's not the last section of 8. So we're going to review next Tuesday, and then you'll take the test on the win day right before that Friday off. So I guess you guys would have it Thursday at the end of the day. My thought was, I guess for you guys it's not going to work out at all. But either way, my thought was, if we have the review day on Tuesday, we have one full normal review day, that like those win times would probably work out really well if you want to use that as like a second review day where you can just schedule to come on in and get help with questions, stuff like that. And or the test doesn't take the 85 minutes we have for class. So I can certainly take like the first 10 or 15 minutes of class on the win day to answer questions before we take the test too. So in terms of reviewing, it should actually work out pretty well with the win days. So this one's called complex fractions, and it's usually the one that most people, if you look at them ahead of time, you're usually the most scared of these questions. Just because they look kind of tough. There's not actually an awful lot going on though. So if you can take it bit by bit, they're going to be pretty easy. And that's why I said you don't need to write this down. This is just me kind of explaining what they are. A complex fraction is when you have a fraction within a fraction. So the name complex isn't going to be like imaginary numbers. It can be, but in this way they use complex as in it's complicated fraction within fraction. So here, we will start with this. And this is a pretty good example of what they're usually going to look like. They generally are going to involve addition or subtraction and of fractions, and then it's going to kind of naturally involve division of fractions because you've got a top and a bottom. So it kind of is like a combination of section 2 and 3 together. So our goal, whenever you have a complex fraction, this is how you want to set it up. You want to set it up as a single fraction divided by a single fraction. Okay, so that's going to always kind of be the start of the problem. Adrian, who are we going to roll first?
Row to C9.
Did you stage that?
No.
I felt like you staged it. Don't be mad at him. Okay. Now, when I wrote single fraction over single fraction, it doesn't mean that it can't already be that. Like, that's just our goal. So if I'm looking at the top, I don't have my voice yet. If I'm looking at the top, is that considered a single fraction right now? No, because there's two fractions being added. How about the bottom? That's why I'm actually asking this question, because it's not always going to be obvious. It's just, is the bottom considered a single fraction? It is. So the bottom would be considered a single fraction, even though there's addition in it. You're not adding two separate fractions, right? So like you've got a couple things on the top, but it's a single fraction bar over x. So the bottom already is. Top is not. Here's what I'd recommend you do for these. Rather than just rewriting everything on each individual line, that will take you, most of you aren't good enough at organization. So what I would recommend we're going to do is go off to the side and kind of do the top as a separate problem. So this is going to be like scratch work, essentially. And we want to write those two as a single fraction, so we want to add them together. Okay, Adrian?
Row 1, seat 6.
She's not here yet. Maybe we'll reserve that one for like in 10 minutes.
Row 4, seat 0.
Well, we don't have a 0. So if you get the 0, you can just roll that dice again.
Okay, row 1, seat 1.
Not here. You've got a talent.
Row 1, seat 2.
Still gone. Do you realize the odds of you doing this like in a row is pretty astronomical?
Row 1, seat 5.
Finally. Okay. So this is back from, we met Thursday. How do I add these two fractions together? Do you kind of remember what we have to go through? True. There has to be a criteria for us to be able to add the tops together. What you said was perfect. So currently they don't have the same bottom number. That's going to be a majority of the work. Do you remember how to give them the same denominator? Close. So currently my denominators are made up out of an x and a 4. And obviously they're not alike. So what we're generally just going to do is multiply them by each other. So this one I'm going to multiply by 4, this by 4, and then this by x, this by x. And then that way both denominators would become 4x. But very good. I mean, it's been a while. There you are. Good morning. Okay, so I've got 8. Believe it or not, Hank, you already got called on even though you weren't here.
Oh, really?
Yeah. I don't know if you want to consider that lucky or unlucky, but you got called on already. Or rolled. You get-
Row 2, seat 9.
Again, we're not going to be that cruel.
Okay, seat
8?
Yeah.
You're exempt. Maybe I should give you the bingo roller. Holy cow.
Seat 4.
Hadley. I guess I kind of did the work, and I was going to ask you this, so I screwed that one up. So I added the tops together, and I got 8 plus x squared. What I'm going to do is I'm going to replace those two that I added together with 8 plus x squared over 4x. Do I have purple? Sure. Good enough purple. Now this is just a little thing, but it's like it helps my mind separate them. I always like to write that middle bar bigger than all the other ones, so it's like my mind can separate what's top, what's bottom. Your question, if you remember it, do you remember what we do when we, instead of dividing fractions? True. Do you remember how to change that? Because we probably wrote them differently than this. This currently says top divided by bottom. Do you remember what we're going to change it to? Which one will you change?
Oh, don't you switch the on the bottom?
keep the first. Yeah, no, what did you guys call it? Keep, change, change?
Change flip.
No.
That is what I thought.
Keep, change, flip, or keep, change, change, depending on who taught you, I guess. Okay, so we're gonna keep the top. I mean, everything you said was good, though. So this is just, it shows it a little different. So keep the top fraction the same, change it to multiplication, and then either flip or change, whatever you want to call it, the second one. Are we okay with what I've got written, though? I mean, that's kind of the big deal, because that's what you guys are going to have to do on your own. Yeah.
Don't the x's cancel each other out?
Well, that was the next step.
Oh.
But yeah, I guess can we just pretend we rolled 3-1?
I mean,
Sure, Bryce. What do you think we should do next?
the x's cancel out.
Cancel the x's? Good, good, good. So when you have multiplication of fractions, you look for things that can cancel. Nothing here factors. So we just basically look for things that can cancel, and we do have that. This x can cancel with this x. And then our final answer, you can write 8 plus x squared, or you can write x squared plus 8. Something tells me an answer key would write x squared plus 8. So just know that it doesn't matter what order you write them, because it's plus. I'm going to keep it because I think a lot of you guys would probably write it like this. And then last person.
Row 1, seat 7.
Angelina. What would I write on the bottom of the fraction? Basically, we have two different answers we could write, but it's up to you. What would you write on the bottom? How come?
Because the 4 and 1, or yeah, multiply.
Right idea, but then if you're going to multiply out the 4, you would have to multiply it to both of them. So you can write it like this and not multiply it, or exactly what you just said, you can multiply it. It's kind of your choice. It's up to you how you like to write it. I'd recommend the one on the left because it's less work. And less work means less chances for making a mistake. How are we feeling comfort-wise with these problems 0 to 5? A shaky 4? Okay. All right. Honestly, that's for seeing your first one, that's pretty good. I don't believe you did any of these in Algebra 1, so there's a good chance this is kind of your first intro to it. Why don't you guys try this one on your own? Or should we do another one together and then try one on your own? Try it on your own? You feeling confident? Basically, do whatever parts you can on your own. If you can't, that's okay. I mean, we'll go through it together, so. First step is already taken care of. Sometimes you have something to do, sometimes you don't. The next thing you guys should do is the keep change change. So that basically should have been like your first step, to be honest. I guess if you factored first, that'd be fine too. I don't know if anybody did that first. There's nothing wrong with that. I was assuming most of you would want to write it like this before you tried factoring. But then factoring would be your next thing to look at because you're trying to see if anything would cancel. Only one thing up here factors. The x squared minus 1 is a difference of squares. So it would be x plus 1, x minus 1. Okay, Adrian, we need a simplifier.
Row 3, seat 9.
Does anything cancel or simplify?
For what?
The x minus 1.
It was 3, 9.
The x minus 1.
Okay, x minus 1 does cancel. Anything from bottom and top when it's multiplied, we can do that. Okay,
Well, then the x plus 1 as well.
that's true. There's an x plus 1 on bottom and top. I didn't say you were. I was just letting you be in charge of it.
I'm not too sure.
Oh. Well, there's nothing left on the top. So if you cancel something, it has to be from bottom and top. So if there's nothing left on the top, you're done. Yep. No, what you did was perfect. Just sounds like you had trouble trying to decide if there was more to do. Okay. What do we write as the answer then? Is it just going to be x?
It's gonna be 1 up, right?
Nice. Yeah, so since x was on the bottom, it still has to be on the bottom. If nothing is left on the top, then you write a 1. And that's what it's simplified down to. Just kind of curious, how many people ended up getting that one on their own? Oh, where did the troubles come from? Factoring? Yeah, I don't know. Yeah, I mean, I guess I don't really much to say to that other than we're definitely going to have factoring in at least the rest of this chapter. I think chapter 9 is on radicals, like root symbols, so there probably won't be much factoring. And then chapter 13 is trig, so there won't be any factoring. So if you are not a fan of factoring, do know that at least it ends with chapter 8, probably.
Do you have a tuition question?
I do. Question, Bryce, or just hand up? Just prop in your head. Okay. I'm kind of thinking I should give you another one to try. Yeah, did you fill it out already?
Yeah.
Okay, sounds good. Oh, not that it matters for my class in any which way, but apparently printing is not working today. In case you guys needed to print something for a class. if you need help starting, the top is not a single fraction. So you need to put those together to start. And I don't know if some of you are getting stuck or if you're just kind of, if you put the two top fractions together, they should turn into 3 over 2x. Yeah,
Don't if you multiply the first one, you have to multiply the second one by something?
no. So all we care about is that their denominators become the same. So did you multiply the first one by 2x and then the second one by x?
Well, I knew that I should multiply the first one by 2 to get it the same, but I thought, like, I was stuck because I thought you had to multiply both of them.
Got you. Yeah, the goal is just that the bottom is the same. So if you need to multiply both of them by something, you do that. If you need to multiply one of them by something, you do that. And then sometimes you don't have to multiply either. Like they might already have the same bottom.
If you multiply them by each other, then what is the 2x squared?
Yep. So if you multiply them by each other, it'll actually still work out in the end. Because if you multiply them by each other, this first one would have become 2x over 2x squared plus x over 2x squared. And then that would give you 3x over 2x squared, which reduces down because an x cancels, and then gives you 3 over 2x. So it's okay if you multiplied by too big of information. Like it's never a bad thing if you multiply by too much. Usually we multiply by the least amount because then it's just less work, but it's not bad if you multiplied by something different. Okay, so top fraction should have been 3 over 2x. Bottom fraction already was a single one, x plus 4 over x minus 2. And then because we're dividing two fractions, now this is the keep, change part, keep the first, which is the top, change to multiply, change the second fraction, and then did some of you get stuck here because you couldn't figure out what to cancel? Okay, nothing does cancel. You don't have to cancel anything, you just look to see if there is something that'll cancel. Like, there's no plain x's on top. These are factors because there's plus and minus, so they're joined. So there's no plain x's on top. There's no x minus 2's on bottom, no x plus 4's on top. Nothing is in common or alike between top and bottom. And so your final answer, you could leave everything written as factored and then just write it like that. If for some reason you want to multiply it, you can. And you could write 3x minus 6 over 2x squared plus 8x. Yeah, go ahead.
Could you cancel it in the second
No. So the -2 is joined with the x. And so if you cancel something, it has to be that whole thing. The only time we can cancel individual parts is if they're multiplied. Like this bottom with the 2 and the x, they're being multiplied, so you could cancel the 2 or the x. But when there's plus and minus, you can't. I'm guessing you're getting a little better at these as we go. Okay, one last problem, and then we will be done. Too far. I don't know if you want to write the whole thing down or not. It's up to you. It's a word problem. I've got the notes saved. Schoology wasn't working for me this morning, so I couldn't upload anything. But we'll see. Maybe it's working now. Either way, I just wanted to tell you that it's saved if you're not feeling like writing everything down. So basically, a train is going one speed to one place, and then it unloaded everything, and so it was able to drive faster on the way back. What's the average speed for the whole trip? Now, I'm assuming a lot of you right away possibly are just thinking it's 35. 30 one direction, 40 the other direction. It's not going to be 35 because it took a different amount of time to travel one of the ways. So average speed is super easy if the amount of time you're driving is the same. Like if you drive an hour at 30 miles per hour and then an hour at 40 miles per hour, your average speed is 35. But on this one, it's going to take longer to drive the 30 miles an hour than it is the 40. And so my guess is the average speed is going to be less than 35. I don't know how much less, but it's going to be closer to 30.
What is R?
Rate. So D equals RT is, I don't even know what science class that's in. What? Yeah, maybe. So it's distance equals rate times time. And that's used quite frequently in a lot of different situations. Average speed is going to be the amount of distance that you went divided by the amount of time. Now we're going to kind of I'll just do this one with you guys because I'm not expecting you to just immediately know how to do it. I'll just put it that way. We don't know how far the train went. But we do know that however far it went there was the exact same amount of distance coming back. Like if you drive to a city and then drive back, well, it's the exact same distance both ways. So what we can say is the distance in one direction is D, and the distance coming back is also D. So since we don't know distance, we'll make that our variable. Now we don't know time either, so, fun. We aren't given much info at all. But we know time can be figured out by taking the distance divided by the rate. So if we add up the time there, the time going there would be the distance you went divided by 30. And then the time going back would be the same distance divided by 40. So we're able to figure out times by, it feels like cheating, but it's not cheating. So the total time, I'm going to add them together. So I'm going to say D over 30 plus D over 40. And this would tell me my average speed. Even though I don't know the distance or the time, it would tell me my average speed. And it ends up being a complex fraction. Okay, top of the fraction, 2d. And then remember that this is what we want. Currently, neither the top nor the bottom is a single fraction. Do you guys remember how to write anything as a fraction when it's not currently? Oh, sorry. You guys were actually being polite. You raised your hands. I didn't notice that. Yeah, you can write it over 1. Ooh, that's not the right color. Must be that. You can write it over 1. So now the top is a fraction. The bottom is not a single fraction, but I can kind of do that off on the side as scratch work to figure it out. So d over 30 plus d over 40. I better call on somebody. You guys look like you got tired quickly. The heat is not helping.
Roll for CA.
Grace. Oh, she's really scared. I don't think she liked that roll. Anything you can tell me? They don't have the same bottom numbers, so we can't add them. How would I make 30 and 40 turn into the same number? In your head, think of 3 and 4. What would be the common denominator for 3 and 4? You think it backwards. What would 3 and 4 both go into? Like 3 goes into 9, but 4 doesn't go into 9. Nope, close. 12. They both go into 12, so that means I'm going to change them both into 120. So I'm going to multiply this one by 4. This one by 3. If you multiplied the first one by 40 and the second one by 30, that's still fine, still correct. This is just going to be smaller numbers. So 4d over 120, that sounds wrong saying 40. 40 and 3d. It sounds like I'm saying 30 wrong, 3d. That would give me 7d over 120. Say what? Oh, did you have a question, Lucas, or something else?
Well, that was me.
That was you?
Yes.
What? Okay, my ears are going bad. What were you trying to ask?
You went from 30 to 40? Or, I mean, you went from 30 to 3? You changed 30 and 40 to 3 and 4.
So I know that both numbers go into 120. So I just multiplied by 4 and 3. If you multiplied by 40 and 30, that's okay, that'll still work.
Yeah, that's okay.
So if the top would become 70D and the bottom would be 1200 if you did that. Still correct. I just like smaller numbers. So I'm going to put 7D over 120 in the denominator. I did my scratch work to give me that answer. And I can't scroll down anymore, so I'm just going to fit stuff up here. Keep the first. Change the symbol. Change the second fraction. And then we're going to reduce if we can. Should we call on somebody for that? Sure. Last person of the day.
Roll for C9.
You almost made it through class. Is anything canceled? It definitely is one of those two.
I feel like the answer is yes, but I don't know which one it is.
Oh, okay. So I'll look at the different parts. 2, if there's something on the bottom that was even, I could cancel, reduce to 2, but there's not. I don't know, 120 is really big, I'm just skip that one. Bottom, 7, if there was something on the top that 7 went into, I could cancel or reduce, but it doesn't. And then the only other thing to look at is the D.
So the D is canceled.
Correct. Because they're not being added or subtracted, they're being multiplied, I can cancel them. So 240 divided by 7 will be the average speed. I feel like that was 34 point something. I like how half everybody just pulls out their phones. I don't know if that's good or bad.
4 from G if you round it up.
Sure. 34.3 sounds good to me. So this would be the average speed. And it's kind of what I said at the beginning. I was expecting it to be a little less than 35. You guys did fantastic for being a Monday morning. I know you were not excited to start the day. But you did good.